Hi everyone, this is the 138th video of the ACT Math Practice Problem series, and here we have an interesting problem from the concept of permutation and combination. As I always recommend, before seeing the solution you can pause the video and give it a try yourself, and after that of course you want to match with my solution. So let's get started. Here the question says, if the vehicle number plates in a state have 3 letters followed by 3 digits, how many unique number plates can be made if the digits cannot be repeated? To solve this kind of problem, we should quickly draw a small little diagram for the positions of the letters and the digits on the number plate. So suppose in this particular example, the positions of the letters would be like this. There would be 3 positions for the letters, and similarly there will be 3 positions for the digits. So here we have 6 positions like this. Now if you think about it, how many options we have for the first position, which is for the letters? So the left hand side 3 positions are for the letters, the alphabetical letters, and the right hand side 3 positions are for the numeric digits, right? So for the first position, how many options do we have? Well, there are no restriction on the letters. So for the first position, obviously we have 26 options because there are 26 letters in the English alphabet. So let me write it like this. We have 26 options for the first position, which is for the letters. And then for the second position, that is also for the letters, again we have 26 options because the letters can be repeated. And then for the third position, which is again for the letters, there also we have 26 options because the letters can be repeated. There is no restriction as such. Now we know how many options we have for each of the positions for the letters. Now let's see how many options we have for each of the positions for the digits. Now the fourth position, which is actually the first position for the digits, there obviously we have 10 options because we have digits from 0 through 9, which are 10 decimal digits. So we have 10 options for the first position of the digits. Now if you think about the second position for the digits, which is actually the fifth position in this whole number, the second position for the digits we have only 9 options. Why? Because we have a restriction that the digits cannot be repeated. That means whatever digit has been used in the first digit position, we cannot repeat that digit. That means we are now left with only 9 options. Alright, now think about the last position, which is the third position for the digits. There again we have one less option than the previous one. Why? Because the digits cannot be repeated. So for the second digit position, if we had 9 options, now for the third digit position we will have even one less option, which is actually 8 options. Since the digits cannot be repeated from one position to the next position, we are left with one less option, right? And now from the fundamental principle of counting, we know that for each of these dependent events, the total number of options would be a product of these numbers. So I'm going to put a multiplication sign in between them. So we have to just take the product of these numbers, and if you punch in these numbers in a calculator, you will find that this actually turns out to be 12,654,720. And if you look at our answer options, we have this value under option K. So option K would be the correct option. I hope everything made sense. Thank you for watching. See you in the next video.